If you're having metabolism problems, I feel bad for you, son. I have 99 problems, but the pentose phosphate pathway ain't one. The primary function of the pathway is to produce NADPH for reductive biosynthesis, which is important in fat-making cells such as mammillary glands, liver, adrenal cortex, and gonads. It is also used to produce ribose 5-phosphate for DNA and RNA synthesis, which occurs in rapidly dividing cells such as bone marrow, skin, intestinal mucosa, and tumours. The PPP is made up of the oxidative phase, which regenerates NADPH from NADP through an oxidation/reduction reaction, and the non-oxidative phase, which generates ribose 5-phosphate for biosynthesis, recycles pentose phosphates to glucose 6-phosphate, and is also used as an intermediate for energy. The oxidative phase starts with glucose 6-phosphate, which gets oxidized to 6-phosphogluconolactone, which results in NADP being converted to its reducing equivalent of NADPH. Phosphogluconolactone gets hydrolyzed to 6-phosphogluconate with the help of the enzyme lactinase. Oxidative decarboxylation then occurs, and 6-phosphogluconate is converted to ribulose 5-phosphate with the enzyme 6-phosphogluconate dehydrogenase, which yields carbon dioxide, NADPH, and pentose phosphate. Glucose 6-phosphate dehydrogenase also plays a vital role in the pathway, as a deficiency reduces the available amount of NADPH, which ultimately results in increased levels of oxidative stress, which greatly impacts the red blood cell structure and function. NADPH is essential in the reductive biosynthesis of cholesterol, fatty acids in adipose tissue, and steroid hormones in mammillary glands, liver, adrenal cortex, and gonads. NADPH helps in defense against free radical damage to prevent oxidative stress to the membranes of our cells. High amounts of NADPH is also used to reduce glutathione and glutathione peroxidase through the action of glutathione reductase, which is vital in maintaining red blood cell structure and function. The non-oxidative phase helps nucleotide biosynthesis, where ribulose 5-phosphate is converted to the primary product of ribose 5-phosphate. In another process that occurs in the non-oxidative phase, more NADPH gets generated and fed into glycolysis, also losing a carbon as carbon dioxide in the process. Transketolase and transaldolase are the two enzymes which convert 3 ribulose 5-phosphates to 2 fructose 6-phosphates plus a glyceraldehyde 3-phosphate using xylulose 5-phosphate as an intermediate. The final mode of meeting metabolic needs is through energy generation, which helps supply energy to glycolysis and the citric acid cycle. Entry of glucose 6-phosphate into the pentose phosphate pathway is dependent upon the needs of the cell and the concentration of NADP. Inhibition occurs when there are high levels of NADPH, preventing the first step of the pathway, which is catalyzed by glucose 6-phosphate dehydrogenase. Stimulation occurs when there is increased NADP during biosynthetic reactions which readily use NADPH. Now you should only have 98 problems, because we've solved the pentose phosphate pathway one.